guys, to week 2 and what is going to be lesson 4 of indices. So just to let you know, so far what have we covered? We've covered what is an indice or an index or power and the base. That was lesson 1. Lesson 2 we looked at writing out algebraic expressions in expanded notation, and then also index notation. And the final lesson of last week was looking at index law number 1. There's 4 index laws in total. Index law number 1 is a shortcut that we can use for when we're multiplying algebraic terms. If you haven't seen those videos yet, please do so before you move on to this one here. And with that being said, if you are up to it, let's get straight into it. Alright, so in this lesson, what do we plan on doing? We're going to do a super brief recap of indices so far, right? We don't want to forget what we've covered. So we're going to start with a brief introduction into what we're doing, and then we're going to move on to the main point of this lesson, which is index law number 2, which is a shortcut we can use when doing division questions. Alright, so if you don't have your maths book and pen with you, definitely pause the video now, get your maths equipment. Once you're all set to go, unpause the video and we'll begin. Alright, you don't need to copy this into your books. This is just a quick recap. I'm just going to go through the 3 different skills that we've covered so far. So as far as expanded notation, so here we have an algebraic, hang on a sec, my pencil is not working. Okay, now we're good. All right, so if we look at this first one here, we have 6a cubed, and we're going to write this out in expanded notation. So what does that mean? Well, you got 6 times, what is a cubed? That's just a times a times a. There's 6a cubed. That's expanded notation. If you really wanted to push the envelope further, I guess you could expand it out even more. And I guess with the number 6, you could break that up into like a 2 times 3 if you wanted. With that being said, that right there would definitely be full marks in an exam. If you want to split that number up, to expand it even further, there's certainly nothing wrong. They'd both be considered correct in any sort of exam. Anyway, that's expanded notation. Index notation. That's where you would do the opposite of expanded notation. We want to write this thing in index notation. That's where there's the powers. All right, so check it out. X times x. That would be x squared. And then here we have y times y times y. That is y cubed. If you would write it as x squared times y cubed, that would be fine, but you're like partially in expanded notation there. You would definitely want to remove that multiplication just to bring it right into index notation fully. Again, with that being said, I strongly suspect you would actually be getting full marks for this middle one here, but as a general piece of advice, simplify it as much as you can. All right, and index law number 1. All right, so here I've got, I guess one of the more challenging questions from the last lesson, right, where the actual question would ask you to simplify here. So you want to simplify this thing. There's 2 different algebraic terms, 1, 2. We're multiplying them together. And we've got ourselves a nice shortcut using index law number 1. Again, if you haven't seen that yet, definitely go back, actually watch the third and do the third indice lesson. It's pretty simple, but definitely, don't take shortcuts. Make sure you go through all the lessons in the right order. How do you do it though? For those that have seen it and just want a quick recap, here you have a perfectly ordinary 7 there, and it has been times by an ordinary 2. 7 times 2, that is ordinary numbers. They times together like normal, and you just get a plain old 14. Now when we actually move on to the unknown numbers, the p's and the q's, notice their bases, they've got these powers above them. That's a 2, 3. This one technically has a power of 1, and the q has a power of 3. By the way, the 7 and the 2 also technically had powers of 1 there, but you can kind of ignore them, right? Okay, so we've got 14 out the front. Now, what do we do with these p's? P squared times, here I'll put the 1 in there in blue, times p to the 1. We learned index law number 1. Keep the base the same. I don't know why I'm in blue. Keep the base the same, add the powers. For the q's, q3 times q3. Keep the base the same, add the powers. And that would be the correct answer for that bottom question. All right, into the new work for today, and this is where you will need your maths book. This is our heading, index law 2. So I'm going to get you to pause the video, get the heading, and this here is our notes for today's lesson. So get all of this copied into your maths book. Once you've got that in, unpause the video and we'll continue. Anyway, when dividing algebraic terms, common factors will cancel out. And of course, we can use index law 2 to shortcut our working out. So again, you see something in maths like a law, and it sounds like it might be something really unpleasant, but I can assure you with indices, you like the laws because it allows us to cut out a lot of the working out and will allow us just to go straight to the answer. Right through this whole topic, if you learn your laws, and there's 4 of them in total, it will allow you to go straight to your answers. All right, so if you've got your notes and heading in for today, on to our next section. So here I'm going to look at, I'm going to ask you to consider n to the power of 5 divided by n squared. Now, in this particular case, if I said to you, and we're going to obviously simplify this, right? We're going to work out what this thing is equal to. Well, just firstly, before we're going to go any further, what actually is n to the power of 5, right? And if you remember from, lesson number 2, when we did expanding, n to the power of 5 means n times n times n times n times n. That is what n to the power of 5 is equal to. What is n squared? Well, n squared would just be n times n, right? There's 2 of them because it had a power of 2. So what we're trying to do here is we're dividing these two things. So n to the power of 5, which we've just discussed, is actually this. This here is n to the power of 5. And we're dividing it. Here I'm using the fraction symbol, but remember that means divide as well. We're dividing that by n squared, which is, again, just as we've discussed, n times n. Now, in this particular case, we've got these n's that are on top and bottom. Now, I would say to you, these n's right there and there, they will actually cancel each other. The reason for this is, if you take, let's say the number, 6, if you times it by a number and then divide it by that number, so 6 times 4 is 24, and then when you divide it by 4, it just gets you back to 6. Ultimately, what happens was those 4s, they undo each other. It's like one of them does something and then the other one just undoes what the first one did. They, in mathematics, is what we call, they cancel each other out. So ultimately having the same number, and of course it only works if it's the same number on the top and the bottom, but they cancel each other out and you're just left with, in this case, the 6. So what does that mean for us up here? We have an n on the top and bottom. They will cancel each other out. And same as these next two n's. They will cancel each other out as well, leaving us with n times n times n, which of course is, right, in index notation, n cubed. This here is the correct answer. So for this question, n to the power of 5 divided by n squared, the answer is n cubed. But as I've been saying, this here, we did not use any index laws, right? We wrote out what it was, we did the cancelling, and we've used our full working out. What's great about the laws is they allow us to cut out all of this working out. The way index law number 2 works is this, right? We saw when you're multiplying, if it was n to the 5 times n squared, the base stays the same, and you add the powers. Well, when you're dividing, instead of adding the powers, all we have to do is take them away. You go 5, take away 2, check it out, you get the 3. That's all you need to do. Base stays the same, you minus the powers. So officially, the way I would have done this question is if we had n to the 5 divided by n squared, all I would do by using index law number 2 is keep the base the same, take away the powers, and check it out. You go straight to the final answer. So officially, the actual law is this. We could write it as something like a to the power of x divided by a to the power of y will just give you base stays the same, you take away the powers. This here in this orange cloud is index law number 2. Every time we're dividing, you don't need to do that working out of writing it out, cancelling top and bottom, and then rewriting it in index notation. You just keep the base the same, minus the 2 powers, and there you are at the answer. All right, so I'm definitely going to get you to get this page here copied into your books as well, right? This here explains why index law number 2 works. And if you ever forget index law number 2, which I guess you probably won't, right? Because all it is you just minus the 2 numbers at the top. But if you ever did forget index law number 2, you get to the exam, oh gosh, how do I do it? Well, of course, if you forget the law, you can still answer the questions. You just have to do it using all of this working out here, right? Expand it out, cancel, and then rewrite it in index notation. But of course, that's not the way I want you to do it. I actually want you to know the law, learn the law, and use the law. So for questions like this, you should just be going straight to the final answer, just like I did down here. That's meant to be an arrow, by the way. All right, on to our examples. There's actually 5 of them in total, so don't get too excited because you can only see 2. There is 5 of them. We will be copying in the examples. Pause the video at any point you need to get the examples copied in. But of course, I will be doing these ones for you. I'll take it from the easiest up to the absolute hardest ones you'll need for index law number 2. So that's 5 questions in total. After that, and I'll explain as I'm doing things, and then there'll be some questions for you guys to do at the end, and then bang, bang, that's it for the lesson. All right, let's check it out. First example, n to the power of 10 divided by n to the power of 4. Forget working out. I'm going straight to the answer. Index law number 2. Keep the base the same, minus the powers. That's it, done. Second question. Now, in this case, there's like an ordinary 6 that's out the front, and it's been divided by an ordinary 2. Ordinary numbers, you just use normal mathematics for. 6 divided by 2 will just give you a perfectly ordinary 3. The A's, however, we will be using index law number 2 because they've got the powers above them. It's not the A necessarily, it's the powers that we have to deal with. And in this case, when dividing, we keep the base the same and we minus the powers. Sorry. I'm going to sneeze. All right, so that's it for example number 2. That's your answer. On to the third one. Oh, by the way, I should mention, I'm writing divided by as like a division here. But, if I go back here, I could have just as easily have written this first one as, n to the 10 divided by n to the 4. right? That also means divide, and you do it just like normal. Keep the base the same, minus the powers. So don't freak out. I think there's one of them in the example, and I think there's a couple in the actual questions where the division has been written, in a different way. If it's like, for example, here, example 5, that still just means divide, right? So it doesn't magically use different rules. Division is division, you minus the powers. And that's exactly what we're going to do here. When dividing, the powers minus. So keep the base the same, take away the powers, so you just live with a 1. Or, of course, whenever there's a power of 1, you actually don't need to write it at all. You could have just left it as A. Either of them would be 100% correct. Example 4 are super tricky. There's 2 different variables. Just do them, separately. X to the 7 divided by x squared, right? So I'm just dealing with this first. Keep the base the same, minus the powers. So you're left with x to the 5. And then now I'm going to move on and look at the y's. You got y squared divided by y squared. And that's going to give you a y to the 0. Or you could view y squared divided by y squared like they cancel each other out perfectly. So like the y's are actually gone in total. So you could write x to the 5, y to the 0, and that is correct. Or you could have just written it as x to the 5, because those y's do cancel out each other perfectly and just leave you with an x to the 5. And by the way, for those that are really paying attention here, what just happens then with a 0 is is something that's going to, it's index law number 4, our final index law. There it is. I've told you, 0 index. Anyway, and you've just seen what you do with it. But again, we'll save that for the correct lesson. All right, and final example. This one here, I've written as a fraction. If we were in the classroom, I would ask you, why do you think I decided to make this choice? And, hopefully someone would point out, well, the 15 divided by 20, like the ordinary numbers that are at the front, when you divide them, they don't turn out just to be a nice whole number. Not like the second one when you had 6 divided by 2. In this case, 15 divided by 20, yeah, they simplify, but they're still a fraction. So we're going to have to write that answer as a fraction anyway. So that's why for this one here, instead of using the normal division symbol, I'm writing my division as a fraction. Anyway, how do we do that? 15 over 20, again, you just pretend you're back in year 7. How do you simplify these numbers? If you hated year 7 maths, or you forgot year 7 maths, or you spent that year in a coma, whatever the situation happens to be, just get out your calculator, type it in, press equals. The calculator will simplify it for you. Ultimately, 15 over 20 will become a 3 over 4, right? They've got that common factor of 5. So you've got 3 over 4. Now let's deal with what's left. Here you have a to the 6, right? And it's been divided by a to the 3. Keep the base the same, take away the powers. Notice the a is going to be left on top because that's the a that had most of them. If the a to the 6 was on the bottom and the a to the 3 was on top, if they were like written around the reverse, it would still work the same. You still minus the powers. Just notice the A3, the A's that are left over, they would be on the bottom of the fraction, not the top. All right, so that's the A's done. Now let's move on to the B's. We have B to the 5 divided by a B to the 1. So you're going to be left with B to the 4. And just because of aesthetic reasons, I'm going to recenter that 4 in the middle. All right, and that's the answer for the final example. So please make sure you have all 5 examples into your books. I've just brought it back to make it easier for you. Pause the video if you need to. Make sure that is done. And then we finish off this lesson with you guys practicing some questions of your own. All right, so copy these questions into your book, pause the video, have a go at answering these first 4 questions. Once you've got the answers, obviously unpause the video because I'm about to put the answers down right now. You should have got for the first one. So pause the video if you need to, if you're still copying them in, because I'm about to put down the answers. Hopefully you got a to the 5 for the first, p to the 9 for the second. This one here, you should have had an a to the 1, or just a, and a b squared for the second part. And this one here, the a's cancel each other perfectly. Again, if you had an a to the 0, that is correct. Still give yourself a tick, but you didn't need to have a's at all. You should have ended up with a b to the 2 and a c to the 6. All right, and your final questions for today. Again, pause the video, copy these in, have a go the best you can. Right, these ones are definitely the trickier ones. Hopefully you found the first 4 pretty easy. These ones genuinely are meant to be tricky, so don't freak out if you are a little bit unsure, but just try your best. And unpause the video once you've got answers, and I'll write down what I've got. All right, so for question 5, hopefully you just had like an ordinary 2 with an x to the 10. Question 6, these ones here, again, is going to stay as a fraction. 4/3, and you should have ended up with an a, which you could throw at the top, an a to the 7. Or if you wanted, you actually could have wrote it, next to it, a to the 7. Or, if you typed 8 divided by 6 into your calculator probably would have wrote it as a decimal for you. Actually any one of those 3, the 1.3 repeater, any of those 3 would be, mathematically 100% correct. So definitely give you a tick if you got one of them. And the last one, it's pretty tricky, like 10/15, right? They simplify down into a 2/3. Again, it's going to be a fraction. 2 on the top, 3 on the bottom. And in this case, the p's, you should have had a p cubed. The q's cancel perfectly. If you've got a q to the 0, either on top or bottom, it won't make a difference. That would also be correct. All right, that's it for today's lesson. If you do have any questions, please feel free to leave it here on YouTube or back on Canvas, and I'll help you the best I can. Hopefully this made sense, and I'll see you guys for the next one. Okay, bye.